Hello and welcome to another Matlab tutorial. In this tutorial I'll talk about logic conditions in Matlab. First I'll start with logic scalars and then I'll pass on to logic matrices and vectors. So to start things easy, I've written this part of a script here and I'll explain what it does. So if, and there will be a condition, there is no condition here yet, but if this condition is accepted as true, it will type in the command window accepted as true. Otherwise, if this condition is accepted as false, it will type accepted as false in the command window, just so we know what is happening. So I'll just start with a equals to 1, so I'll define a variable a as 1, and I'll just type if a here as my condition. So a will be a double variable, not a logic variable. It could be 10, 20, 30, whatever I wanted. However, if Matlab encounters in a condition a double value, it will be accepted as true if the value of that condition is different from 0. So this would be the same as writing a equal 0. But let's just keep a for now, so you see that this works. So 1 is different from 0, so it should be accepted as true. Let's run the script, and as you can see in the command window we see accepted as true. Now let's try, for example, another number, like for example a equals to 10. I'll hit save and I'll run it again, and as you can see it was again accepted as true because, well, 10 is different from 0. Now let's try a equals to 0, so you can see that it will also be accepted as false. So accepted as false. And now let's try a equals to minus 1, for example. So you can see that negative numbers will also be accepted as true because minus 1 is different from 0. Okay, and it was accepted as true. And once again, I'll repeat, you should have written the condition this way because this is much more readable to the user and it's a more correct way of programming. So let's now try, for example, different conditions. So if I wanted to test if the value a was equal to, for example, 45, and I run the script again, so a is equal to minus 1, not 45, it should go to the false part. And I'll run it. And indeed, it was accepted as false. Now let's try, for example, if a is smaller or equal than 45. Minus 1 is indeed smaller or equal than 45, and if I run the script, it will be accepted as true. If I put 45 here, which is also less or equal than 45, it will be again accepted as true. Now, what if I wanted to see if a is smaller or equal than 45 and b, that I'll assign for now the value 30, is larger or equal than 15? I'll make an AND condition here, so I want it to be true if a is smaller or equal than 45 and if and only if b is greater or equal than 15. I'll save it again and I'll run it. So a is indeed less or equal than 45 and b is 30, which is larger than 15, so this condition should return true. And let's run it. Okay, it was accepted as true. Now let's change this condition for b to be larger than 15, and let's type b as 15. So 15 is not larger than 15, so, and this is an AND condition. If this is false, the whole condition will return false. I'll run it, and indeed it was accepted as a false condition. Now I'll show you the OR condition, and the OR condition works as if this is true or this is true, it will be accepted as true. So this might be a logical true and this might be a logical false, and it will still be true. So if there is any of these that is true, the whole condition will be true. So now let's run the script, and it was accepted as true. Why? Because, well, this is false, but this is true. And as this is true, it will be accepted as true because all condition will be true. I could make, for example, combinations of these. So let's now type c equal to 0. And let's, for example, put parentheses here, and then condition here, c is equal to 1. So let's analyze this first. So we have seen that this condition is false, this condition is true, and this condition will be false because c is equal to 0, not equal to 1. So one thing that is true and one thing that is false with an AND condition will be accepted as false. Let's run it. And indeed, it was accepted as false. This covers the basics of scalar logic conditions, and I'll talk about matrix and vector logic conditions. So I've written here a vector A that has components 30, 0, 12, and minus pi, so it is a logic vector again, and I've written the same first condition as before. Now, when A is a vector, it will essentially apply the same condition here as default. So it will apply the condition equal 0. And let's see what this condition gives us when you do it in the command window. So, as you can see, this condition returns a 0 on the first position, 1 on the second one, 0 on the third, and 0 on the fourth position. Well, because 30 is not equal to 0, so this is false. 0 is indeed equal to 0, so this is true. 12 is not equal to 0, and minus pi is not equal to 0. However, here I'll still have a logic vector. So what will Matlab do? Well, the rule for Matlab is apply ANDs in between the conditions. So if any of the conditions is false, it will be declared as false. So let's run the script so you see this working. And as you can see, it was accepted as false because there was only one condition that was true. If, however, A was a vector full of zeros, like this, now run the script again, it was accepted as true. However, Matlab will not like, and this will still not be a clear way of programming, as I should have done the following to simplify the problem. Let's type the vector again. So it was 30, 0, 12, and minus pi. To make it clear that I should always use ANDs in between the components of the answer vector, I should write all, and the function all will apply that exact condition. So if all the components are true, the answer is true, otherwise it's not true. So, as you can see, it will be now compressed as a scalar logical if I use the function all. So, for that reason, I'll put all here. And now we know that this is only true if all the components of A equals to 0 are true. So let's run it so you can see it. As you can see, it was accepted as false, like before, because these components will result in a false condition. Now, I could do the same with other vectors. So let's type a vector B that is 12, 34, 34, 12. Let's hit save, and I'll put an OR condition here. And instead of using 2 vertical bars, I'll have to use 1 because we are dealing now with vectors. These would be for scalars. And I'll type, for example, B bigger than 0. So let's see what this will do. Is B bigger than 0? Yes, all the components of B are bigger than 0, so B bigger than 0 should return a vector that is full of 1s, so a 4-dimensional vectors with 1s. Is A equal to 0? Well, only on the second component. It will be, as we've seen before, 0, 1, 0, 0. However, with an OR condition here, and all the components of B holding true, the result that is here will also be a vector that is a 4-component vector that is true, so full of 1s. Let's run this so you see it. As you can see, the condition was accepted as true. However, let's change something about B, and let's put the first component of B 0, and let's analyze this condition again. Is B bigger than 0? Well, not the first entry of B, so it will be 0, 1, 1, 1. So this condition will return 0, 1, 1, 1. And as I'm using an OR statement, and the last condition of A, that is minus pi equal to 0, that will give 0, so false. A false or a false will also return false. So I know that the last condition of this logical vector will be false, and therefore this will return false. Let's check it. As you can see, it was accepted as false. Now let's do the same with matrices. So I have 2 by 2 matrices here, and the first matrix is just an identity matrix, so 1, 0, 0, 1. And the second matrix is 12, pi, pi, and 3. Now let's make some changes here. And let's put A equals to 0, so that should return a matrix that is 0, 1, 1, 0. And B is bigger than 0 should return a matrix that is full of 1s. And as this condition is true and we are in an OR statement, this should be true and this should be true. Let's check it. And it was indeed accepted as true. Now let's just put here a minus 3 and check this condition again. So this will return true, 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 and false, because 3 is not larger than 0. And as we've seen before, this is still the same result, so 0, 1, 1, 0. However, as the component 2, 2 of these results and the component 2, 2 of this result are both 0, this will return a matrix that will have the component 2, 2, 0, and therefore this will return 0, so false. Now let's run it again, and as you can see, it was accepted as false because of this. This is everything I wanted to talk about logical conditions in Matlab. Thank you very much for watching. If this tutorial helped you, please consider subscribing and liking this video. As always, I hope to see you in another tutorial.